Alright, well I'm going to go ahead and go over some of the data that we found or that was recorded on the temperature sensor devices that was recorded onto our LabVIEW program, and I went ahead and converted it into a Excel file. First up, we're going to look at our first commercial phone data readings. Just a quick little introduction about the temperature sensors. The temperature sensors give off or give back a voltage reading, and then from there we convert it using the formula given on the temperature sensor data sheet, and that formula we then use that to convert it to a temperature, as you can see here. All of these temperatures that you see are in degrees Celsius, so keep that in mind as you're observing. So as you can see, each voltage reading was captured every 0.02 seconds. So I'm going to go ahead and skip through this. I don't want to take too much time, but if you want to look at the bottom, I've went ahead and recorded the max and mins. The max for the temperature 1 sensor, I forgot to mention, on the left side, I guess we'll go back up. On the left side for this temperature 1 sensor right here, this is corresponding to your inside sensor, meaning that it is the sensor between the phone itself and the battery. And so as we look down to this temperature 1 sensor, the maximum temperature that I experienced is 19.0694 degrees Celsius, and the minimum temperature it experienced was negative 11.5126 degrees Celsius. Going back up, this temperature 2 sensor data, which corresponds to these voltage readings. This temperature sensor is the outside sensor, which is attached to the surface of the phone, the outside surface. Once again, we're going to scroll down, and the max temperature that was experienced by that sensor was 15.9958, and the minimum was negative 11.4686 degrees Celsius. So basically, probably wondering what this means. Just a quick overview. For the inside sensor, they both pretty much experience the same low temperature of around negative 11.5 degrees Celsius. Even though the temperature device in the thermal vac chamber was set to negative 20 and it reached negative 20 degrees, it wouldn't be necessarily experienced within the full atmosphere, given that 15-minute interval for both extremes of negative 20 and 40 degrees Celsius. So basically at negative 20 degrees Celsius, after 15 minutes, the temperature sensor only went down to negative 11.5 degrees Celsius for both sensors, for the inside and outside sensor. So this shows that there's quite a deal of insulation, I guess you could say, inside the phone and its components. It won't experience any drastic changes of temperature just because of the outside temperature changes. Also to note that there was a difference between the inside and outside temperature for the for the max temperature ranges. My assumption is that due to the battery heat created that was touching the sensor inside the phone, this is what created the difference. Obviously there's current within the battery caused by the chemical reactions that discharge the battery, so this would create heat. Thus right here, this is 19.0694 degrees Celsius, while the temperature sensor on the outside of the phone is only 15.9958 degrees Celsius. We're going to go ahead and take a quick look at our second commercial phone. Once again, your temp sensor, your first one, which corresponds to the AI0 voltage data readings, is the temperature sensor on the inside of the phone, and then the temp sensor 2, which corresponds to AI1, corresponds to the outside temperature sensor. Please note that the AI2, I wanted to add that as a constant for this test, just to make sure that we had some good temperature sensor readings. And basically what I did, I created a constant that should stay around the same, because there's obviously nothing attached to it, no temperature sensor or anything. So This looks good, pretty much all around 1.4 around that area, so that's alright. So let's go ahead and look at the inside temperature sensor between the battery and the phone itself. I'm going to go ahead and scroll to the bottom again. I've recorded the min and max for this as well. Sorry there. Alright, here we go. For the HTC Incredible 2, we have the minimum temperature of negative 11.5126, and for the inside sensor, and for the outside sensor, we have a minimum of negative 14.0206. Now, this is interesting because for our first commercial phone, their mins were about the same. However, for our second commercial phone, they're a few degrees off, and it begs the question why. Some possible reasons could be that the battery of our second commercial phone was not able to generate as much heat or produce as much heat compared to the outside of the phone and its close by components to the surface. So what I'm saying is that the battery ended up being a little bit colder than the components close to the outside of the surface of the phone. This is not necessarily a good thing, because a cold battery can sometimes mean a malfunctioning battery. However, this wasn't the case. Afterwards, we checked out the batteries in the phone, and they both seemed to be charging and discharging quite fine. As for the maxes, once again, this is expected. As our first commercial phone, the inside temperature, which was close to the battery, had a higher max than the outside sensor. Once again, this is most likely because of the heat produced from the battery, as shown here, because of this close proximity to the battery itself. So just to sum everything up, the Droid, this was the thermal vacuum chamber temperature sensor data readings from our first commercial phone and our second commercial phone. Now, what this shows is that after careful observation of the lens and the recording capabilities of the phone afterwards, both phones performed the same after the test and before the test. So this proves that this phone can withstand temperatures from at least negative 11.5126 or around negative 11.5 for the Droid Charge minimum, and max around 20 degrees Celsius for the Droid Charge. And for the HTC Incredible 2, it can survive a temperature around negative 11.5 to 20 degrees Celsius. Now, of course, you might be wondering, well, I thought we were going to experience around negative 40 to 40 degrees Celsius. This is true, and this test does not show that it could go down to that. However, if I were to do this test again, something I would change is, instead of making the intervals for the max and for the extremes, as I should say, of negative 20 degrees Celsius and 40 degrees Celsius, I would allow that time interval to increase. For example, at negative 20 degrees Celsius, I would go ahead and let that phone sit there and experience that temperature for a couple hours instead of 15 minutes. And then same thing with the other extreme. For 40 degrees Celsius, I would let that temperature be experienced by the phone for 2 hours or 3 hours. Just so we can see what happens when the temperature does change to this. But what this also does show is that this phone can be maintained quite well, because over these few hours, or over these couple hours, even though the temperature around it and the environment was going to negative 20 degrees and all the way up to 40 degrees Celsius, it was able to insulate itself in a sense, preventing it from going to from outside these temperature ranges drastically. So if it did change temperature, it changed gradually, nothing extreme. And this shows that a simple heater can prevent it from getting too cold. However, we're not going to attach, which we are going to. We are going to attach a heater to the cell phone between the battery and the phone itself. Reason being is that according to our first commercial phone, there's a warning and a disabler that if the battery gets too cold, the software operating system in our first commercial phone stop charging the cell phone device, and that's a problem. So we do need to keep the phone at a high enough temperature. However, we're not going to install a way, at least in this test, in the HASP flight test, we're not going to install a way to keep it cool. I don't think we're going to need to keep it cool. It was able to last pretty high temperatures, close to 20 degrees Celsius. We might, the graphs that I've shown that have shown in some of the research I've done about the previous HASP flight tests, they did go to 40 degrees Celsius. However, they didn't stay constant there. So we're going to see what exactly this phone can handle on this HASP flight test. And that's it for this data. So we're going to go ahead and move on. And thank you for watching. Hey everyone. What you just saw was my initial thermal vacuum test. Hope you guys enjoyed it, and hope it was very informative to you guys. I'll show you a little bit of video on a little explanation of another test I wanted to do. You can call it a extreme test. I wanted to test some extreme pressures that we wouldn't see on the HASP balloon. However, I just wanted to see how far we could take this phone until it broke. So look forward to more clips. Thank you.